Good to go for the team here. The JAXA team, our colleagues there in Japan, also all set to go. Everything is on track for liftoff again at 2:48 p.m. Central Time. Of course, the Tanegashima Space Center, one of the most beautiful launch centers in the entire world, unfortunately is going to be dark whenever this rocket lifts off, so we won't get the spectacular views that we've seen before. But this vehicle, this HTV on top of its H-2B rocket, is always a spectacular launch nonetheless. But we will stand by as we continue to count down these final 47 minutes before this rocket lifts off. Rollout of rocket and cargo vehicle occurred late last night here in the United States. It was early in the morning there in Japan. This rocket actually rolls out on a device that is nicknamed Dolly. They are rolled about 400 meters from the vehicle assembly building where the rocket and the cargo vehicle itself are mated together out to the launch pad. This trip takes about 30 minutes. It is moved atop a mobile launcher, which also serves not only as the vehicle to take the rocket out, but also as the launch pad itself. As we talked about, Dolly is the nickname of the special transporters that take this huge vehicle out to the launch pad. Each Dolly has 56 tires, and the unique thing about it is that it can move forward, backward, to the side, or even rotate around 180 degrees. Fueling occurred just several hours later after the rocket was secured to the launch pad itself, and the countdown began here shortly before we came on the air. But you get a good look there of this seaside launch pad and just the beautiful ocean there back behind the rocket itself. The terminal countdown started here just before we came on the air. All systems are go. They've been doing some checkouts of the communications systems around the launch pad. They have cleared the launch area itself, and again, launch is scheduled for 2:48 p.m. Central Time. The exact time is going to be 2:48 p.m. and 46 seconds. That is when liftoff should occur. You see the 4 solid rocket boosters around the rocket itself. Those will burn out at an altitude of about 30 miles up at 2:50 and 43 seconds. The first pair, the first 2, will jettison just a few seconds later at 2:50 and 53 seconds. The second pair will jettison just 3 seconds later at 2:50 and 56. And then the fairing that's protecting the HTV itself, which is up there at the top, will jettison at an altitude of 75 miles high. That will occur at 2:52 and 26 seconds. A couple of minutes later, 2:54 and 43, that is when first stage engine cutoff will occur. The first stage will separate from the second stage at 2:54 and 40 seconds. The second stage will then ignite at 2:54 and 51 seconds, with cutoff happening several minutes later at 3:03 and 1 second. And then HTV itself should separate from the second stage at 3:03 and 35 seconds once it is up in orbit. At the time of launch, the International Space Station will be flying 260 statute miles above Russia, right there on the border with Kazakhstan. The Expedition 36 crew on board the orbiting complex will be awake. They will be watching our broadcast here on NASA television, getting ready to greet this vehicle as it arrives up to the International Space Station coming this Friday morning. Of course, we'll have live coverage here on NASA television. Our coverage will begin at 5 a.m. Central Time. Capture should occur a little more than an hour and a half later at 6:29 a.m. Central Time. Both Chris Cassidy, Karen Nyberg, 2 flight engineers on board the International Space Station, will be at the controls of the station's robotic arm as HTV, and you see this animation here as it flies up toward the bottom side of the International Space Station there close to the U.S. segment, and the Harmony node, which you see there on the end. The 58-foot long robotic arm will be used to reach out and grab HTV, just like has been done on previous flights. Also is done to the SpaceX Dragon vehicle and the upcoming orbital Cygnus vehicle, almost the exact same maneuver. HTV will be rotated around where the hatch will face the bottom side of Harmony, the Earth-facing side of that portion of the station. And then the crew will inch by inch close in HTV to the bottom side of the station and will ultimately install it. We will have two separate broadcasts that day. Like I mentioned, the one at 5 a.m. Central Time that will bring you live coverage of the capture of HTV. Then our second broadcast will begin at 8 a.m. Central Time. That is when we will bring you live coverage of the actual installation of the vehicle on the bottom side of the station. This HTV cargo craft itself is fairly large. It is 33 feet long and 14 feet wide. Just by itself, it weighs more than 10 tons. It can take up to 6 tons of cargo. This time it's got 3.6 tons on board, but you see the breakdown of the different modules there. You see the propulsion module there on the far right-hand side. It's about 6.5 feet long and carries all of the fuel for HTV itself once it gets up into space. There are 4 propellant tanks that carry 2 tons of fuel on each flight. There are 4 main thrusters you see there at the back. They're located on the bottom of the propulsion module itself, along with 16 reaction control system thrusters. Another 12 thrusters are located at the top of the HTV for a total of 28, which allow it to steer up in space. Next, you see the Avionics Module there, second from the right. This contains the guidance, navigation, and control system, as well as the communications, data handling, and electrical power systems for the vehicle. All of these systems combined help the HTV fly on its own during the trip up to the International Space Station from now to Friday. The Avionics Module is about 4 feet long. The next section is the Unpressurized logistics carrier and its contained exposed pallet, which you see there on the inside. This section is 11.5 feet long and has a wide opening on the side that takes care of that exposed pallet. That is where it is housed. That exposed pallet is basically a big tray that the crew uses to reach in and extract out. It carries on it some unpressurized parts for the outside of the International Space Station. There is a grapple fixture on it that the station's arm is attached to, and the crew can use it to remove it and steer it around. There's also an interface that allows the pallet to connect to the Kibo Laboratories exposed facility. You see Kibo there in the animation there in the center of the screen, that exposed facility, sort of the front porch for Kibo. But basically that pallet can be plugged into Kibo and used for communication and experiment work as all these items are moved around. The final section of HTV is the pressurized logistics carrier. You see it there on the left-hand side. This section is almost 11 feet long and carries all of the cargo that is used on board the station. There's a hatch on one end of the HTV, which we mentioned in the previous animation we showed you, that actually attaches to Harmony. But that is what the crew will use to open up and get access to all of this cargo that's on the inside. Inside the pressurized section you see there are 6 resupply racks that carry everything from food to water to experiment hardware and samples to clothes and other items that the crew needs. There's also 2 science racks on board, as well as experiments in human research, physics, biology, biotechnology, and also education. There's also an ISS cryogenic experiment storage box you see on the bottom left-hand side. There is a freezer refrigerator of Stirling cycle, which is called Frost for short, and also the reentry data recorder, which is going to be used whenever HTV comes back into the atmosphere to gather some data. Of course, HTV is destroyed upon reentry. It does not come back to Earth, but that is an important function because the crew will use the next month while HTV is up there to pack it full of trash and other items that they no longer need, and it'll be disposed of in the Earth's atmosphere at the conclusion of the mission. Back now with a live view of the Tanegashima Space Center. The Space Center was opened up in 1969 when the original National Space Development Agency of Japan was formed. HTV is going to be lifting off from launch pad number 2. That is the traditional launch pad for these HTV cargo crafts. This will be the 4th time that HTV has flown up to the International Space Station. As we mentioned, the rendezvous with the International Space Station will take place on Friday morning, while Chris Cassidy and Karen Nyberg are flying the station's arm with HTV on the end of it. Luca Parmitano will be monitoring it from the International Space Station. The crew has a small control panel that they can use there inside Kibo to send commands to HTV. So he will be working alongside Cassidy and Nyberg as well. The very first HTV flew up to the station in September of 2009. The second one was a little more than a year and a half later in January of 2011. And then HTV-3 flew back last year in July of 2012. So again, this will be the fourth one. All of these HTVs carry the nickname of Konotori. That means white stork in Japan, so you may hear it referred to as that. All systems are go. The launch team there in Japan continuing to count down and do a systematic performance of checks to make sure that the rocket is ready for liftoff at 2:48 p.m. Central Time. As we mentioned, once they got within 60 minutes of launch, they did begin what they call the terminal countdown, working through the final steps leading up to liftoff. They've done the attitude control system checkouts. Everything went according to plan. They've tested the radio frequencies between the launch site and the rocket itself. And of course, they fully fueled the rocket here earlier in the evening Japan time with all the liquid oxygen and liquid hydrogen that will power this rocket uphill. This H-2B rocket that you see there on the launch pad that will carry HTV into space stands 186 feet tall. It's fairly sizable. It has two engines down at the bottom. It uses, as we mentioned, liquid hydrogen, liquid oxygen to fly up into space as propellant. There are 4 strap-on boosters, which you see there down at the bottom of the graphic. They help power the flight during the first several minutes of ascent. The 2 liquid-fueled engines on the bottom of the first stage will also be ignited as well. Soon after liftoff, the rocket will conduct a pitch maneuver to steer it toward the southeast and head out over the Pacific Ocean. And as we mentioned, those SRBs will jettison at 2:50 and 53 seconds. That's the first pair. The second pair will follow about 3 seconds later, 2:50 and 56 seconds. The fairing that covers HTV will stay on until 2:52 and 26 seconds. These times are all Central Time. At that point, the rocket will be 75 miles high. First stage engine cutoff will occur at 2:54 and 43 p.m. Central Time. First stage separation will occur at 2:54 and 40 seconds. Second stage ignition, 2:54:51. And second stage cutoff at 3:03 and 1 second. As we continue to take a live look at the Tanegashima Space Center and count down during these final 30 minutes leading up to the liftoff of HTV at 2:40 p.m. Central Time, we want to take a look at the cargo that's on board. As we mentioned, there's 3.6 tons of cargo heading up to the International Space Station. There you see several different pieces, the HTV resupply racks. That's basically what the crew will see whenever they look inside the hatch. There's a freezer, refrigerator, a Stirling cycler nicknamed Frost on board. There is a Space Station Cryogenic Experiment Storage Box, or ICE box, fairly creative name for that. There's also a re-entry data recorder, or the eyeball as it is called. That'll be used whenever HTV departs the station and heads back into the Earth's atmosphere. All in all, 3.6 tons of cargo. There is 5,372 pounds of pressurized cargo, including quite a bit of water that's on board. There is 1,880 pounds of unpressurized cargo that is on the exposed pallet that we showed you earlier. That is the tray that's sort of in the side of the HTV that the crew will extract after HTV actually gets up and gets attached to the station. There is a spare, as we call it, MBSU, which is a multi-bus switching unit. This is part of the power supply of the International Space Station. It helps all this power come in from the solar arrays and route it to different portions of the station. But you see the MBSU, the main bus switching unit there on the left-hand side of the graphic. It's a small box that'll join some other spares on the outside of the station. There's also a spare utility transfer assembly that is for the mobile transporter. That's sort of the railroad car that's on the outside of the station that can move the station's robotic arm back and forth across the truss. And there's also an upgraded space test program payload for the Department of Defense here in the United States that has all sorts of different experiments on board. That'll stay up on board station while it gets exposed to space. And then the number 3, the previous version of that experiment, will be put back on the exposed pallet and put back inside HTV and sent back down into the Earth's atmosphere. Also on board, some new supplies for one of the major experiments outside the station known as RRM. This is the Robotic Refueling mission. This is a look at the actual device that is on the outside of the station on an express logistics carrier. This is a portion of the station's truss right underneath the famous alpha magnetic spectrometer, technically on the right-hand side of the station, even though it looks like it's on the left of your screen. But the station flies toward us, so it's technically on the starboard side. But RRM is a large washing machine-sized experiment that the Dexter robot, one of the robots outside the station, basically operates on, and goes through a lot of testing of cutting wires and moving some things around and refueling. The point of this is to hopefully one day be able to fly robots up to satellites, even the ones that are out up in geosynchronous orbit, about 22,000 miles out, and resurface them. As of right now, there's really no way to do it. So those satellites are basically limited by when they break down or when they run out of fuel. And of course, they're very expensive. They're pretty far out. If there's a way to fly a robot up there and repair it, refuel it, obviously that would be of benefit to not only the companies that own the satellite, but also would prevent a lot of space debris from accumulating as these satellites sort of break down. So the team that put together the Hubble servicing missions up at the Goddard Space Flight Center have put their heads together and come up with a way of testing this robotic refueling mission on the outside of the station. This activity began in earnest here within the last few months. But HTV is going to be carrying up some new supplies, a new task board for RRM, and also a pretty nifty little object that is known as the RRM On-Orbit Transfer Cage, or the ROTC for short. What this will allow the crew to do is bring the supplies from HTV inside the station that are for RRM, to put them in this cage device, and to put them in the airlock that is part of the Kibo laboratory and slide it outside, so they don't have to go outside and do a spacewalk. So they can basically just put it in there, push it outside, and use the station's arm or the Kibo arm itself, along with Dexter, to pick up the supplies outside and go to work. So it's a pretty interesting device. Of course, if you would like to learn more about that, just log on to the NASA website at nasa.gov/station, and we have a feature story up there now where you can read all about it. We are now roughly 25 minutes and 34 seconds away from liftoff from HTV. Everything go. We are green down the board. As we mentioned at the top of the broadcast, the team here in Houston has given their final go to the launch team there at the Tanegashima Space Center. That team also going through their final steps and everything counting down fairly smoothly.
X-25 分。
This is Mission Control Houston, now T-minus 22.5 minutes before the liftoff of the HTV on its journey up to the International Space Station. Of course, HTV is just one of several vehicles that visits the International Space Station. We have the Soyuz vehicle that takes up the crews and brings them back to Earth after 5 or 6 months. But in terms of cargo vehicles, the Russians have their Progress resupply vehicles that fly up 4 or so times per year up to the International Space Station. They dock with the Russian segment. The Europeans have the Automated Transfer Vehicle, or ATV, which currently there is one, the Einstein ATV, that is currently on orbit, also part of the Russian segment. HTV will be docking with the U.S. segment of the International Space Station. The crew will be grappling this vehicle and installing it on the bottom of the Harmony node. It is also where in the United States we have the Dragon spacecraft that is, of course, built by SpaceX. We've had a few missions now. And then coming up soon, Orbital Sciences will be sending up its Cygnus, what they call the Advanced Maneuvering Spacecraft, the cargo vehicle, as part of NASA's COTS program on a demonstration mission up to the International Space Station. It'll fly a profile very similar to what HTV does. That mission currently scheduled for the middle of September, but it is going to be bringing up about 1,600 pounds of cargo during this test flight. And if all goes well, Orbital will then join SpaceX and HTV and ATV and the Russian Progress and the fleet of cargo vehicles that come up to the International Space Station. It is quite a busy time. It's going to be a very busy September for the crew on board the space station. HTV itself is going to stay up there for about a month after it gets up there on Friday. And it will be detached and deorbited on September the 4th. That is when it will actually be removed from the International Space Station and sent into a destructive reentry the next day. That is being done deliberately to make way for the Cygnus, is the sort of space traffic control takes place over the next several weeks. So there's also some Soyuz vehicles departing and arriving during September. So it's going to be a busy time over the next month and a half for not only the ground teams here in Houston and around the world, but also for the crews up on board.
X-20 分。
As the camera pans up, you're getting a sense of the size of this behemoth of a rocket. It stands more than 180 feet tall. The familiar orange foam on the outside of the tank, reminiscent of the shuttle external tanks, of course, uses the same kind of fuel, liquid hydrogen, liquid oxygen, that combine for the engines down at the bottom. It also has 4 strap-on boosters, SRBs, on the side that will power during the first couple of minutes of flight. Those will burn out and then come off 2 at a time. We want to read you the ascent performance times one more time. Launch again at 2:48 and 46 seconds p.m. Central Time. These are all in Central Time. The SRB burnout will occur at 2:50 and 43 seconds at an altitude of 30 miles high. The first pair of solid rocket boosters will be jettisoned at 2:50 and 53. The second pair will be jettisoned at 2:50 and 56, so those happen pretty much back to back. The fairing up at the top that protects the HTV during the first few moments of flight will be jettisoned at 2:52 and 26. That happens at about 75 miles up. First stage engine cutoff, 2:54 and 32 seconds, 2:54:32. First stage separation about 8 seconds later, 2:54 and 40 seconds. Second stage will kick on at 2:54 and 51. Second stage cutoff will occur several minutes later, 3:03 and 1 second. And then the HTV will separate from the second stage and be in orbit at 3:03 and 35 seconds. Once HTV gets up into orbit, its preliminary orbit will be 124 by 186 miles. That is 200 by 300 kilometers. It'll be pretty elliptical at first, but that'll be corrected over the next several days as HTV will conduct a series of burns to circularize its orbit and head on up toward the International Space Station. It'll be launching into a 51.6 degree orbit, just like the International Space Station itself. Less than 16 minutes now before launch, the final go, no-go poll from the Tanegashima Launch Control Center will occur in about 5 minutes. Of course, we'll bring that to you live as we hear it. The final go, no-go here in Houston has already been conducted, but everything proceeding according to plan.
X-15 分。
T-minus 14 minutes and counting. All systems still green. There you see the fire pit on the far left-hand side of the screen. That is burning off the excess propellant that is being vented from the launch pad. As we mentioned, the rocket itself has liquid hydrogen, liquid oxygen on board. Same sort of fuel that the space shuttle used to use. Of course, down at the Kennedy Space Center, they also burned off fuel, but our fire was not quite as spectacular as the one you see there on the left-hand side of the screen. Approaching the T-minus 13-minute mark. Again, the final go, no-go poll for the Tanegashima launch team will occur in about 3 minutes.
最終カウントダウン進行判断の結果を連絡します。
We would like to inform you of our final go, no-go decision.
現在、各系ともロケット打ち上げの最終作業を実施中です。また、警戒区域の安全が確認されており、気象条件も打ち上げに支障のないことが確認されました。
All systems are now in final operations. All safety measures were confirmed in the restricted areas. Also, the weather conditions were examined and confirmed.
従いまして、宇宙ステーション補給機コウノトリ4号機を搭載した H2B ロケット4号機の打ち上げを本日日本時間の午前4時48分46秒に実施します。
As a result, we are to launch the H2B launch vehicle number 4 with the HTV-4 named as Konotori 4 on board at 4:48:46 a.m. Japan Standard Time today.
打ち上げ10分前になりました。種子島宇宙センター竹崎総合司令塔から H2B ロケット4号機の打ち上げ状況をお伝えしております。
It's 10 minutes to launch. This is a live report of the H2B launch vehicle number 4 launch from the Takesaki Range Control Center at the Tanegashima Space Center.
まもなく打ち上げられる機体は関係者による最終的な確認作業が続けられており、現在のところすべて順調との報告を受けています。
According to the launch site operators, they are now performing the final checks, which are all progressing well.
宇宙ステーション補給機コウノトリ4号機を搭載した H2B ロケット4号機は昨日19時30分からターミナルカウントダウン作業を開始し、現在はその最終段階にあります。
The terminal countdown operations for the H2B Flight 4 started at 7:30 p.m. last evening, and we are now in the very final stage.
打ち上げ8分前より打ち上げに向けた秒読みが開始されます。
The final terminal countdown will start at 8 minutes prior to launch.
So that report there from the Tanegashima Space Center Launch Control. We're now at T-minus 8 minutes and 35 seconds before the liftoff of HTV. Everything proceeding according to plan. In just about a half a minute, they're going to get ready to conduct the final terminal countdown. That'll take us down to liftoff at 2:48 and 46 seconds p.m. Central Time. It's going to be 4:48 and 46 seconds a.m. there in Japan. But they've given the final go. All the systems are green, ready to support the launch. The weather is as good as can be expected. It's about 72 degrees and partly cloudy there, even though it's dark. But we're at T-minus 8 minutes and counting.
打ち上げ8分前です。打ち上げに向けた秒読みが開始されました。
It's 8 minutes to launch. The final terminal countdown starts.
種子島宇宙センター竹崎総合司令塔から H2B ロケット4号機の打ち上げ状況をお伝えしております。
This is a live report of the H2B launch vehicle number 4 launch from the Takesaki Range Control Center at the Tanegashima Space Center.
現在、各系ともロケット打ち上げの最終作業を行っております。また、警戒区域の安全は確認されております。
All systems are now in final operations. All safety measures were confirmed in the restricted areas.
440 430 29 28 27 26 25 24 23
T-minus 7 minutes and counting.
21 420 19 18 17
安全系準備完了。
The range safety system is ready.
13 12 11 410 409
車上系準備完了。
The range system is ready.
406 405 404 403 402 401 400 390
T-minus 6 minutes and 20 seconds. As you heard just a few seconds ago, the range has been cleared. The range control system is ready to support the launch. Everything on track. Launch time 2:48 and 46 seconds.
370
T-minus 6 minutes and counting.
360
打ち上げ6分前です。現在、車上の天候は晴れ。気温、摂氏 28.1 度。北西の風、毎秒 4.8 メートルです。
350
H2B ロケット4号機の打ち上げに問題はありません。
It's 6 minutes to launch. The current weather here is fine. Temperature is 28.1 degrees Celsius. Wind is 4.8 meters per second from the northwest. We don't have any problem for launch.
本日の打ち上げ予定時刻は日本時間の午前4時48分46秒です。
Today's scheduled liftoff time is 4:48:46 a.m. Japan Standard Time.
320
Approaching the T-minus 5-minute mark, the International Space Station now passing over parts of Africa, heading up to the northeast over parts of the Middle East.
307
It'll be right over the border between Russia and Kazakhstan right at the moment of launch. The Expedition 36 crew is awake and watching our broadcast as this cargo vehicle gets ready to head up toward them for a rendezvous on Friday.
The HTV-4 is ready.
290、89、88、87、86、85、84、83、82、81、280、79、78、77、76、75、74、73、72、71、270。
自動カウントダウンシーケンス開始。
The automatic countdown sequence starts.
種子島宇宙センター竹崎総合司令塔から H2B ロケット4号機の打ち上げ状況をお伝えしております。
This is a live report of the H2B launch vehicle number 4 launch from the Takesaki Range Control Center at the Tanegashima Space Center.
現在ロケットの管制は吉信発射管制塔から行われております。
The launch vehicle is currently controlled from the Yoshinobu blockhouse.
T-minus 4 minutes and counting.
240、39、38、37、36、35、34、33、32、31、230。220。210。200。
一段液体水素系準備完了。
The first stage liquid hydrogen system is ready.
88、87、86、85、84。
T-minus 3 minutes and counting. The rocket is ready for launch at 2:48 and 46 seconds.
打ち上げ3分前です。
It's 3 minutes to lift off.
170。
全システムの電源が外部から内部に切り替えられました。
The launch vehicle is switched to the internal power.
T-minus 2 minutes and 30 seconds. They're switching over to internal power of the rocket. It is in control now. Again, this cargo craft has 3.6 tons of supplies for the crew of Expedition 36 that will arrive at the station on Friday morning.
34、33、32、31、130、29、28、27、26、25、24、23。
T-minus 2 minutes and counting.
120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105。
一段液体酸素系準備完了。
The first stage liquid oxygen system is ready.
99、98、97、96、95、94、90。
T-minus 1 minute, 30 seconds.
91、90。
2段液体酸素系液体水素系準備完了。
The second stage liquid oxygen and hydrogen systems are ready.
82、81、80、79、78、77、76、75、74、73、72、71。
フレームデフレクター冷却開始。
The launch deck flame deflector cooling starts.
66、65、64、63。
T-minus 60 seconds and counting.
61、60。
打ち上げ1分前です。
It's 1 minute to lift off.
57、56、55、54、53、52、51、50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34、33。
T-minus 30 seconds and counting.
散水開始。
The launch deck water curtain starts.
28、27、26、25、24、23、22、21、20、19、18、17、16、15。
フライトモードオン。
Flight mode on.
T-minus 10, 9, 8, 7, 6, 5, 4,
All systems are
3, 2, 1, ignition. And liftoff. Liftoff of the HTV on a journey to the International Space Station.
宇宙ステーション補給機コウノトリ4号機を搭載した H2B ロケット4号機は平成25年8月4日午前4時48分46秒に種子島宇宙センターから打ち上げられました。
We had a liftoff of the H-2B launch vehicle number 4 with the Konotori 4 on board from the Tanegashima Space Center at 4:48:46 a.m. on August 4, 2013, Japan Standard Time.
And 35 seconds into the flight, and the familiar scream of the HTV as it heads uphill.
総合司令塔に引き継がれています。
After liftoff, the launch vehicle operation control was shifted from the blockhouse to the range control center.
ロケットは現在初期飛行方位角を 108.5 度とし徐々に南東方向の太平洋上へ飛行しています。
The H-2B is now flying over the Pacific Ocean to the southeast with its initial flight angle of 108.5 degrees.
60
打ち上げ後1分が経過しました。
It's 1 minute after liftoff.
ロケットは正常に飛行中であり種子島、内之浦の各地上局は正常にロケットの追尾を行っています。
The H-2B is flying normally, and the Tanegashima and Uchinoura stations are tracking the launch vehicle very well.
80、81、82、83、84、85、86、80、
1 minute 30 seconds into the flight, all systems go.
90。
Standing by for SRB burnout.
110、11、12、13、
SRBA 燃焼終了。
SLBA burnout.
Burnout confirmed.
19、120。
SRBA
First pair jettisoned. The second pair will follow here shortly.
The first and second pairs of SLBAs were jettisoned.
O 小笠原局でのロケット追尾が開始されました。
The Ogasawara station has started tracking.
A fairing that surrounds the HTV at the top of the rocket should be jettisoned here in less than a minute.
打ち上げ後3分が経過しました。
It's 3 minutes after liftoff.
第1段エンジンの燃焼は正常。制御系、飛行系ロケットは順調に飛行を続けており、現在の高度は約 107.9km、秒速約 2.3km です。
The first stage engine combustion, attitude control, and flight trajectory are all normal. The flight goes very smoothly. Current altitude is approximately 107.9 kilometers. Velocity is approximately 2.3 kilometers per second.
衛星フェアリング分離。
Payload fairing jettison.
The fairing has been jettisoned. The next milestone will be the first stage engine cutoff. That should occur here in less than about 2 minutes.
ち上げ後5分が経過しました。
It's 5 minutes after liftoff.
ロケットは順調に飛行を続けており、現在の高度は約 160km、秒速約 4.3km です。
About 30 more seconds left in the first stage engine.
Current altitude is about 160 kilometers. Velocity is approximately 4.3 kilometers per second.
Standing by for first stage cutoff.
第1段エンジン燃焼停止。
First stage engine cut off.
Cutoff confirmed. The first stage should be dropping away here shortly from the second stage, and the second stage will ignite.
ロケットから分離。
First and second stage is separation.
第2段エンジン燃焼開始。
Second stage engine ignition.
So right on time, the second stage ignites and powers the rest of the flight. The second stage will burn for about the next 8 minutes or so, and then it will cut off, and then separation will occur at 3:03 p.m. Central Time.
Ground station has started tracking.
Again, this vehicle is taking with it 3.6 tons of supplies for the Expedition 36 crew, including quite a bit of science and crew supplies, as well as some new tasks for the important Robotic Refueling Mission, or RRM. This is a live look at the Scuba Space Center as the JAXA team there monitors their vehicle as it flies up into space. Now 7 minutes into the mission. This is the fourth time an HTV has flown up into space. The first one was back in 2009 in September of that year, the inaugural mission. The second HTV flew in January of 2011, and then the third one was in July of last year. This particular HTV will stay on board the station for about a month. Its final day will be September the 4th.
After liftoff.
第2段エンジンの燃焼は正常。制御系、飛行経路も正常です。現在の高度は約256km、秒速約 5.6km です。
The second stage engine combustion, attitude control, and flight trajectory are all normal. Current altitude is about 256 kilometers. Velocity is about 5.6 kilometers per second.
HTV is already more than 161 miles in altitude, continuing to burn that second stage engine up until about 3:03 and 35 seconds p.m. Central Time. That is when it'll cut off and be separated. But again, the HTV is going to stay on board the station until September the 4th. It'll be detached by the crew, and then on September the 5th, the next day, it'll be sent into a destructive reentry. Its job would be finished at that point. This is to make way for quite a bit of traffic that is happening up on board the station with Soyuz rotations, both launches and landings, as well as the important orbital Cygnus mission that is going to be happening in the middle of September. This will be the final flight of NASA's Commercial Orbital Transportation Services program. And after that flight is complete, and assuming it is successful, the Cygnus vehicle will join HTV as well as ATV and the Progress vehicle as well as the SpaceX Dragon as part of NASA's cargo fleet of resupply vehicles. Now approaching the 10-minute mark into the flight of this HTV.
打ち上げ後10分が経過しました。
It's 10 minutes after liftoff.
ロケットは順調に飛行しています。ロケットは種子島内之浦の各地上局から捕捉範囲を離れ、小笠原のおよびグアム局から追尾されています。
The flight is progressing smoothly. The launch vehicle is out of tracking range of the Tanegashima and Uchinoura station, and the Ogasawara and Guam stations are tracking it.
第2段エンジンの燃焼は正常、制御系、飛行経路も正常であり、ロケットは現在安定した飛行を続けています。現在の高度は約 288km、秒速約 6.4km です。
The second stage engine combustion, attitude control, and flight. The flight goes very smoothly. Current altitude is approximately 288 kilometers. Velocity is about 6.4 kilometers per second.
So HTV now almost 180 miles up in the air. It's moving close to 4 miles per second.
小笠原局がロケットの追尾を終了しました。現在、グアム局から追尾を行っています。
The Ogasawara station finished tracking, and the Guam station is now tracking the launch vehicle.
ロケットは現在安定して飛行を続けています。
The flight goes very smoothly.
Less than a minute to go in the second stage burn that is being conducted now, powering these final few moments of flight. The second stage should be shut down at 3:03 and 1 second. And then about 30 seconds later, that is when HTV will be separated from the vehicle itself and will be on its way. There are 2 burns planned for later on this evening and 1 for tomorrow. This will continue to correct the course of HTV as it bears down on the International Space Station. Again, our rendezvous scheduled for Friday morning.
第2段エンジン燃焼停止。
Second stage engine cut off.
Second stage engine cutoff confirmed, right on time.
ロケットは飛行を続けています。
The launch vehicle is in coast flight.
What you're seeing on your screen appears to be playback from our JAXA colleagues of the SRBs coming off the vehicle during the first couple of minutes of flight. There goes the fairing separation.
HTV-4 分離
HTV-4 separation.
So at 3:03 p.m. Central Time, HTV reaches space and is in orbit. It has been separated from its second stage of the rocket. Both the JAXA and the Tanegashima Space Center teams there applauding.
補給物資を搭載したコウノトリ4号機は宇宙ステーション
The sun just beginning to rise there in Japan.
The Konotori 4 carrying supply goods left for the International Space Station.
We should be getting some replays here shortly of the launch.
これをもちまして
But just to summarize, launch did take place on time at 2:48 p.m. Central Time, 46 seconds.
終了いたします
HTV reached orbit at 3:03 p.m. Central Time.
The HTV launch vehicle number 4 with the Konotori 4 on board.
今後のコウノトリ4号機の状況につきましては記者会見並びにプレスリリースにて発表いたします。種子島宇宙センター竹崎総合司令塔よりお伝えしました。ありがとうございました。
The flight status of the Konotori 4 will be announced at the press conference as well as through the press releases. This report was from the Takesaki Range Control Center at the Tanegashima Space Center. Thank you very much.
Again, this is a live view of the Tanegashima Space Center, that beautiful area of the world. Too bad the sun was not up when we had our launch, but the launch spectacular and awe-inspiring nonetheless. HTV lifted off at 2:48 and 46 seconds p.m. Central Time. That was 4:48 in the morning there in Tanegashima. The vehicle performed as expected. Everything went according to plan. The SRBs did separate as planned, and then the fairing came off. The two stages separated. The second stage powered for the rest of the flight. And then at 3:03 p.m. Central Time, 4:03 p.m. Eastern, HTV reached orbit after separating from that second stage and after second stage engine cut down. The vehicle has 3.6 tons of supplies on board that is going to be heading up to the International Space Station. There are two engine burns that will take place later on this evening. The first one should take place at about 10:19 p.m. Central Time. And then the second one should take place a little bit before midnight at 11:51 p.m. Central Time. There is one tomorrow on Sunday as well. And then there's a few more mid-course correction burns as HTV continues this 6-day journey up to the International Space Station. Our coverage on Friday morning of the rendezvous of HTV once it gets up to the area of the station will begin at 5 a.m. Central Time. This is a live view from the Tanegashima Space Center. We're getting reports that the Space Center itself has eyes on the International Space Station. That dot you see there on the screen should be the space station flying overhead. The station right now currently over the Pacific Ocean at an altitude of about 265 miles. But of course the space station moves at about 5 miles a second. A little bit tricky to capture on camera, as you can see from it bouncing around here. But inside that little tiny dot is the crew of Expedition 36. They were awake, watching our broadcast here on NASA television as we brought you live coverage as HTV launched from Tanegashima. And now they're looking down on the launch site itself as they continue down toward the southeast over the Pacific Ocean. At the moment of liftoff, the space station and the crew were high above the border between Russia and Kazakhstan at about 260 miles, and now they're over the Pacific Ocean. And of course, as we mentioned, the Tanegashima team there getting their view of the International Space Station as it passes overhead in the early morning hours there in Tanegashima. As you saw from our live shot just a few minutes ago, the sun just beginning to rise. That is typically the best time that you can see the space station flying overhead, even over your hometown, is in the early morning hours or the early evening hours, whenever it's still dark where you are, but the sun just beginning to either rise or set while it lights up the huge orbiting complex. Of course, it's very easy to spot. It's usually the brightest object in the night sky besides the moon. And if you would like to find out when you can spot the space station over your hometown, just log on to nasa.gov/station. NASA.gov/station. There is a spot the station link there on the left-hand side. Now replays from the Tanegashima Space Center as liftoff occurred once again at 2:48 p.m. Central Time.
SRBA 点火リフト
SLB ignition and liftoff.
宇宙ステーション補給機コウノトリ4号機を搭載した H2B ロケット4号機は平成25年8月4日午前4時48分46秒に種子島宇宙センターから打ち上げられました。
We had a liftoff of the H2B launch vehicle number 4 with the Konotori 4 on board from the Tanegashima Space Center at 4:48:46 a.m. on August 4, 2013 Japan Standard Time.
打ち上げ以降ロケットの管制は吉信発射管制塔から竹崎総合司令塔に引き継がれています。
After liftoff, the launch vehicle operation control was shifted from the blockhouse to the range control center.
ロケットは現在初期飛行方位角を 108.5 度とし徐々に南東方向の太平洋上へ飛行しています。
The H2B is now flying over the Pacific Ocean to the southeast with its initial flight angle.
小終了
SLBA burnout.
17、18、19、120。
SRBA 第1ペア分離第2ペア分離
The first and second pairs of SLBAs were jettisoned.
ロケットは現在完成飛行を続けています。
The launch vehicle is in coast flight.
HTV-4 分離
HTV-4 separation.
補給物資を搭載したコウノトリ4号機は宇宙ステーションへ向け
So again, back now with a live view of the Tanegashima Space Center. HTV is in its preliminary orbit of 200 by 300 kilometers or 124 by 186 miles. That's going to be changed a bit over the next several hours. There were 2 engine burns scheduled for later on this evening. The first one is going to be at 10:19 p.m. Central Time. The second one's going to be at 11:51, a little bit before midnight Central Time. And there's some both tomorrow and throughout the next several days as HTV closes in on the International Space Station. Taking a look at our coverage plan for later on this week on Friday, August 9th. That'll be Rendezvous Day. Our coverage begins at 5 a.m. Central Time here on NASA television at 6 a.m. Eastern Time. At 6:29 a.m. Central, that is when the HTV will be grappled by the station's robotic arm. At the controls will be Chris Cassidy and Karen Nyberg with Luca Parmitano monitoring as these three work to snag the HTV out of the sky and get ready to install it on the bottom side of the Harmony module. We will return that morning at 8 a.m. Central Time for our berthing coverage as HTV gets ready to be installed on the bottom side of Harmony like we talked about. At about 8:30, that time is not specific, but around that time, that is when the actual installation of HTV will begin. Of course, for all the latest, just log on to the NASA website at www.nasa.gov/station. We will be posting regular updates and reports there every day during the upcoming week as HTV heads up toward the International Space Station. And of course, join us every day at 10 a.m. Central Time this week for Space Station Live. We will see you back here Monday morning. And of course, we will see you also on the web at nasa.gov/station. We thank you for joining us. We'll see you next time.